hopefully capacitor half shift হয়ে যাবে, okay? So right, so last class we introduced capacitors. I went to the basic principles behind it. আজকে কি করব? So আজকে I'll explain you the process of charging, discharging, the equations related to it, and if time permits, the derivation of the discharge equation as well. Okay. So, anyways, শুরু করি আমরা. So quickly, just a reminder, what's the capacitor? So capacitor is a device that wait, screen protects. Yeah, I don't know where the screen went. Yes, there. So yeah, you have your capacitor. Capacitor symbol হচ্ছে two parallel plates like that, and this is the original version of a capacitor. For our future, we understood the spiral would be better. So spiral exists for it. There's spherical ones as well, with none of which we need. So yeah, I have a capacitor here. Now let's try to understand the charging process, and also let's try to understand the way it charges. So I'll explain what that means again. So you have your battery here, and you need to charge a capacitor. So before we start, let's just do a quick recap. What is a capacitor? It's an electrical component that stores energy within charges. Okay, so it's not a charge storing device, it's an energy storing device, but you have to store the energy within something, right? So what's used there? Charges. Okay, so charge use kora hoy to store energy out there, and a capacitor typically comes neutral. Neutral means it doesn't have any charge or anything inside it. You have to charge it. So how does the charging process work? So you connect it to a battery, and what happens is, so you connect it to a battery, and what happens is the negative charges from this plate, they get attracted to the positive and they move here. And the negative charges from here get repelled and they gather up there. So total number of charges is always the same. It's just that they get redistributed. You're creating something that you might recall was in your O-levels induction chapter. It's called charge separation. Like when you take a neutral object and you bring it next to a charge object, what happens? The plus goes one way, the minus goes the other way. So is that object charged or is it still neutral? Still neutral, right? But কি হচ্ছে এক সাইড প্লাস হয়ে যাচ্ছে আর সাইড মাইনাস হয়ে যাচ্ছে। So এখানেও সেম হচ্ছে। এখানে যেটা হচ্ছে is that you have electrons that are pushed from this side. So আমরা electrons এর উপর ফোকাস করব. The electrons are getting pushed from the left hand side, and these electrons will move like that, like that, like that, like that, and they'll come and stored here. Now, why would the electron stick here? When I think can take it. So easy reason is, can you tell me what's the other plate charge? Yeah, exactly, right? So if this is positively charged, wouldn't the electron feel like it has a chance to get there, right? But it can't. Why not? Yeah, in between there's something called a dielectric, which is like an insulation. So it'll never go there, but it'll always stay there because it feels like there's a way to get there, right? So it actually electron gelo. So eventually more and more electrons will start to show up because they're getting repelled, and the electrons will start to build up here. And as the electrons start to build up here, what happens? So let's try to see that. So we will plot a graph here. Okay, so graph easier. We'll plot a graph for charge versus voltage. Okay, so this is going to be charge, Coulomb, and the x-axis is going to be your voltage or potential difference. So what does the graph look like here? Let's try to understand this. So the first thing that you need to know is what is the definition of voltage? The definition. What is the definition of voltage? Yes, work done per unit charge, or the energy stored per unit charge, or the energy transferred per unit charge, right? If it's the total energy transferred per unit charge or Coulomb charge, that's called EMF. If there's a difference in the amount of energy transferred per Coulomb charge, it's called potential difference. They're collectively called what? Voltage, right? So as the charges build up here, aren't each charge particle here bringing some energy? So wouldn't I be able to say that gradually voltage বাড়তেছে? Can a voltage বাড়তেছে? Because charge আসতেছে, and charge কি নিয়ে আসতেছে? Energy. Wouldn't that mean like there's voltage out there? Now, if you don't understand that logic, there's a much easier logic out there, which is this battery that you see here has a potential difference across it, right? Like a EMF across it. So let's say the battery here has a voltage of 10 volts as an example. Okay. If they ask you why is current going to flow in this circuit, মানে এখানে কেন current হচ্ছে flow করবে from here to there, or why would the charges flow from here to there? The easy simple answer is what? Because there's a potential difference, right? But gradually কি হচ্ছে, if I put a voltmeter here and I start to observe what's going on here, I'll start to notice that more and more charges build up at the top, and that causes the watt to increase there, the potential difference, right? So এখানে যে vটা থাকবে এটা বাড়তে থাকবে, and it'll keep increasing until the voltage across my battery and the voltage across the capacitor become what? Equal. That's when we say the capacitor is what? Fully charged. So what's the maximum ability of a capacitor to get charged? When the potential difference across the capacitor is equal to what? The potential difference across the battery. This battery push করতেছে. So এখানে যেটা হচ্ছে, you'll see that the voltage keeps increasing, and the voltage that keeps increasing here is because of what showing up in the capacitor, electrons and charges, right? So more and more charges are speaking it, more and more voltage of it. Now, I'll ask you a very simple question. What if there's no charge in my capacitor? What's the voltage? Zero. So a graph, the graph that I have here should be a graph that starts from where? Origin, right? And for every charge, the voltage that's given is going to increase linearly because every charge brings a certain amount of energy, right? So eventually, once you look at the graph here for a capacitor, it's actually a straight line passing to the origin like that. A graph for what? Charge versus voltage. This is how the graph looks like, okay? Now, we'll try to find certain quantities from here, and then we'll try to explain what capacitance is. So, can you tell me, if I had a graph here that went this way, how would you compare this capacitor, right, with the other one? A capacitor graph, it's steeper, right? What's different about it that makes it steeper? Capacitor, the same graph now. Graphic gradient, I understand, but what might be different about the other capacitor? Yes, better efficiency, no. Lower capacity. The steeper one has lower capacity or higher capacity. Graph দেখে কেমনে বুঝছো low voltage high capacity? Capacity বেশি। Right, exactly. So you jumped ahead. I'm বললি কি হচ্ছে, so আমি একটা simple এটা দেখে demonstration. Let's say I draw a line here. It carefully দেখো কি দেখাবো তোমাদের এখন. So I draw a line here, and this line is for a value of a voltage. Okay, এই লাইনটা এটা একটা random voltage নিলাম. Can you tell me, for this potential difference or voltage, which capacitor can store more charge? Very obvious, the blue one, right? So wouldn't it be appropriate to say the blue one has a higher capacity? But if for the same voltage, doesn't the blue one can store more charge? So wouldn't it be appropriate to say that it can have a greater capacity of charge, right? And that's what this gradient of the graph gives you. So the gradient of these graph gives us a quantity that we call capacitance. And capacitance is the measure of capacitor's ability to store charge. Okay, so it's called, right. So we come across our first formula here, which is Q equal to CV, right? So Q equals to CV, and that means capacitance C is equal to what? Q divided by V. So if you're given a capacitor and you want to know its ability to store charge, what do you look for that in the capacitor? You look for this gradient here. It's called capacitance. So আমাদের যদি কোনো সময় কেউ compare করতে বলে two capacitors, right? What would we compare? The gradient of this graph. And the one that has a higher gradient has a higher capacity. And that's what capacitance is, okay? So from this graph, we come across our first equation here, Q equals to CV. Let me emphasize the importance of this equation. So the equation that Q equals to CV is the V equals to IR of this chapter. Do you remember V equals to IR, the Ohm's law? And I don't know if you recall V equals to IR, the in a circuit, right? Q equals to CV, there you can do everything in a capacitor circuit. So this is your go-to equation. Whenever you get a question, the first thing you look for is Q equals to CV, because that's mostly what is supposed to be, okay? So Q equals to CV. I think Q is the what? Yeah, charge stored in the capacitor, okay? Charge in capacitor. What is V? The potential difference across the capacitor, or a voltage caliper, potential difference across capacitance or across capacitor. And what is my C going to be? It's called capacitance. Okay, I've seen a lot of students call it capacitor. Capacitor is the name of the device. Capacitance is how you measure it. Similar to resistor is the name of the component. Resistance is what? The measure of it. Okay, so take a bola chalo capacitance. What's the unit for capacitance? Farad. And of course coulomb per volt, but it has its own name. And this is potential difference V and charge tabe coulomb. Okay, so yeah, this is the equation that dictates how a capacitor circuit behaves. Q equals to CV. This is our first equation out there. I'll just give you one reminder again. We find that when you charge a capacitor, charges start to move like that, and they start to build up here. As the charges start to build up here, key bere jay, voltage bere jay. Now, I'll compare two capacitors, and you probably will understand why this equation is like this. So imagine, ekhane 10 volts er jonno, eta 10 volts hoye gelo. Okay, I'm charging this, and this became 10 volts. We consider this to be completely charged. Cannot 10 volts a completely charged consider kora hobe? Because the voltage at the bottom and the voltage at the top is same, right? And one very simple fundamental idea in circuits of charges can only flow if there's a what between 2 points. Potential difference. Okay, so upar jodi 10 hoy, niche jodi 10 hoy, which one is more positive? Neither, right? So the charges don't really have a particular preference. Okay, but jodi 9.99 hoito or 10 hoito, wouldn't it still have some difference, right? To move korto. So for this potential difference, how many charges did I manage to squeeze into this chamber here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 electrons that made to this capacitor. In what voltage? 10 volts, right? Ekhon ami jodi hocche ekhane more charges dite partam for the same voltage, wouldn't that mean this capacitor has ability to store more charge for the same potential difference? Mane jodi 10 volts er moddhe, if I could do this, right, wouldn't it mean that this capacitor can store more charge for that same criteria? Then we can call this capacitor what? A higher capacity, and that's what capacitance is. Okay, so capacitance literally means the ability of a capacitor to store charge for a certain potential difference. Okay, so amar ekhane dhoro je look at these two graphs that we have here. This is the red capacitor, this is the blue capacitor, right? If I draw a line here for voltage and I see the values for my capacitance or charge, this is how much charge is stored in the red capacitor. This is how much charge is stored in the blue capacitor. Doesn't the blue capacitor store more charge for the same voltage provided? That's why we say it has higher capacitance. And that all boils down eventually to what? This equation here, Q equals to CV. And the gradient of the graph is your capacitance. Okay, so yeah, this is the first thing. I think it's your definition, but you need to know the equation, Q equals to CV. Is it clear? Okay, so এখন what we'll do is we will look into the charging and discharging process, but তার আগে হচ্ছে আরেকটা জিনিস দেখাবো তোমাদেরকে. So I'll bring the graph here. We'll investigate this graph right now. কারো কোনো কোয়েশ্চেন থাকলে আমাকে একটু বলো. Right, so just screen it one more time. A capacitor is a device that's used to what? Store energy. Store energy, but what energy just can't be stored. Something has to store it, right? Either chemicals will store it or something like a rubber band will store it. Something has to be there that stores it, right? What's used here? Charges. Okay, so charge will get tool use for a now. Where's the energy? How do you find the energy? So can you once again remind me? I think we'll be doing this for every chapter now onwards. Subject asset. What's the formula for electrical energy? Huh? E equals to QV. When the last chapter course, a chapter for each chapter, E equals to QV, and Q is what? Charge, and V is what? Potential difference. Now, if I want to find the electrical energy stored in my capacitor here, diagram How can I do that? So just by looking at the graph, can you figure out what quantity of the graph may be responsible in helping us find out the energy stored? Voltage. I'm বলছি what quantity of the graph will help us find the energy in the capacitor? কি বলছিল? Area. Yes. Because if you find the area of the graph, aren't you multiplying the x-axis by the y-axis? What's my x-axis? Voltage. What's my y-axis? Charge. So shouldn't the area under the graph give you the energy stored? Acha. So that's easy. And I found everyone like understand that pretty well, that the area under the graph will actually give you what? The energy stored. But there's a issue here. And a issue or a question banai. Issue হচ্ছে, if you find the area under the graph, it's a what shape that you see right now? Triangle, right? And if I want to find the energy stored in a capacitor, E equals to, is going to be half QV. Do you agree? Because it's a triangle. So half QV. That's all good. And it is actually true. If you find the energy stored in a capacitor, it is indeed the what under the graph, area under the graph. But the complication around this behavior, which is, how did the energy end up in the capacitor? Let's see. So energy কোথা থেকে আসছে? কেউ বলতে পারবা? From the battery power source, correct? So এখন আমরা যদি একটু চেক করে দেখি ব্যাটারি কতটুকু এনার্জি দিচ্ছে, we'll find there's a big discrepancy. মানে something is not adding up. So দেখো কি হচ্ছে? So I have a battery here whose voltage is V. It is sending out electrons here, charges of value Q, and the charge stored in my capacitor is Q. And what's the voltage going to be across my capacitor? Potential difference V. মানে যখন fully charged হয়ে যাবে, we just derived that the energy stored in the capacitor is given by what equation? E equals to half, yeah, that, right? But if you go back to your O levels and if you remember what was the formula for electrical energy provided by a battery, what was it? Just QV, VIT, QV, right? তার মানে এখানে the energy that we provided to the system, energy in, is QV, but the energy stored is half QV. Exactly half of the energy is missing. And I'm talking about that's why capacitors by design, without any efficiency issue, just by design, has what efficiency? 50%. And then in reality, it's even less because there are other factors, right? So the question is, why? Why is it that the amount of energy you store and the amount of energy you provide are half of each other? Half can be exactly, it is advanced for you. But can ফুলটা যাচ্ছে না, ওটা বুঝাও। কি ইউজ করে এনার্জি? হ্যাঁ, তো এটা অল্প হতে পারে, পুরো হাফ চলে যাবে আর দিকে চলে যাচ্ছে না, তাহলে তো এটা অ্যাসিস্ট করবে আরো। You have already given them energy and taken them, right? So এটা রাখতে হয় না। হ্যাঁ, correct. তার জন্য আচ্ছা, you had a point. Arc, I think. আচ্ছা, না, ওটা হয় না, ওটা হলে capacitor stops working. So if anytime charges go from one plate to the other plate, right, the capacitor is no more capacitor. It's just a short circuit. Okay, so why is it half? So let me explain. The reason behind that is, so let's try to understand the physics going on here. So the physics in a capacitor is that, in terms of actual equations and everything, is that you have charges that are flowing from where? From the power supply to the capacitor. So let's say you're the first electron that left the battery and is on its way to the capacitor. Do you think you'll have a complicated journey ahead, or is it going to be like a free road? Free, right? This is like an open road, right? In fact, you'll be the fastest. You're getting the best attraction from the other side, the greatest repulsion from the other side. So you'll just go very fast and just go there and stay there. এখানে রাখা problem না কিন্তু, because there's what on the other side, a positive plate, it will keep you there. But then imagine the next electron, which is on its way. Will it feel the same amount of ease, or will it be slightly difficult for the next electron? Yes. Yeah, because there's already an electron in the plate, right? Doesn't it mean that the potential difference is less than before? Doesn't it mean that you're going to overcome some repulsion to get there, right? So yeah, it should be fine. But then imagine this, that over time, there are electrons stacking up, lots and lots of them. So many that 10 to the power 23, 10 to the power 34, এরকম number of electrons stacking up here. What about electrons that are coming in now? Do you think that they'll have a smooth journey, or it'll be actually quite difficult? The electrons that are moving in right now, ওদের জন্য কি মুভমেন্টটা খুব ইজি হবে, or do they need to do work against repulsion? Yeah, so if they have to get there, they have to use some energy. যে এনার্জি পুরোটা ছিল ওটা ইউজ নিয়ে যেতে পারবে না. Some of it will be wasted, and some of it will be wasted to overcome the what from the capacitor repulsion. Okay, it's like throwing a ball up in the air. If you throw the ball up in the air, the higher it goes, it has to sacrifice energy, and that's what we did in the last chapter, right? The potential, right? So এখানে কি হচ্ছে, as it goes up, it starts to lose energy, and it then becomes, goes and stores there. So more and more electrons যাচ্ছে, more and more, what do you need to do? Work, right? And eventually it turns out that if you fully charge a capacitor, the total amount of energy that is used to overcome the repulsion is exactly how much of the energy you provide. Half. Exactly half. Why? I mean, it can বুঝাতে পারবো না because it needs integration. There's a function of half CV square, or can integrate করলে দেখবো the energy stored is like an exact half function. Eta, by the way, I'll give you parallels to it, and এটা হচ্ছে জিজ্ঞেস করতে না, but I discussed it before. A spring, and a spring, when you apply force on it and you stretch it, you're doing work. How much work are you doing? Force into distance. But if you find and recall the equation for the energy stored in a spring, it is not force into distance. Half fx, half kx square, right? But where is the other half energy? I did give the energy, but where did it disappear? So as you try to pull the spring is trying to pull you which way? The other way. So don't I need to do, progressively more work to bring it down, because it's pulling me more the other way? And turns out exactly how much energy is stored compared to what you have provided. Half. And there's actually a thing in a RT syllabus, which I don't know why they got rid of it. It was actually very interesting to do. Springs and capacitors are same. I know you might be wondering, like, how? The way they behave, right? The physics behind them, the way repulsion and attraction interact is exactly same as a capacitor. So some of you probably have done the chapter in school. You'll find combination of spring equations is the same as the combination of capacitor equations. They were capacitor combined করা যায়, and ওরা যখন combine হয়, they behave exactly the same way if you had combined what instead? Springs. Okay, so এটা আর নাই, so I won't focus on it. But capacitors could be strange actually. It has same behavior, like in terms of interaction as springs. It also has the same behavior as the interaction of radioactive decay. The radioactive decay so the radioactive decay graph. That exact graph is the same for what? A capacitor losing its charge. So the capacitor is like a fascinating thing. It's basically the universe doing what its norm is. And universe normally will check the E function follow for it in every decay scenario. So it is taken, okay? But coming back to our scenario here, can you tell me what is this? This is the energy. How would I label this? Yes, energy loss word ওরা পছন্দ করে না. Yes, energy dissipated or energy used to do work against repulsive forces in the capacitor. Okay, so energy dissipated due to right, so that's exactly half. So that brings us to the equation for energy stored in the capacitor. It's half QV, and I highly discourage using this equation. Please don't use half QV, okay? যত avoid করতে পারো avoid করবা, আমি বলি কেন math দিয়ে দেখাবো একটু পরে, but avoid করবো, okay? So আমাদের equation কি আসবে for capacitor? E equals to half QV, as I mentioned. But তাহলে কি use করবো যদি energy বের করতে দেয় if I'm not allowed to use QV? I will use a variation. So Q equals to what? Now Q equals to CV, right? So if that's the case, then can't I write this as E equals to half CV times V? And what do we have here? Half CV square. This one is actually a good equation. Eta use korba sob shomoy. You can be very safe in knowing that হচ্ছে এখানে কোনো mistake হওয়ার chance হয় না. Half QV তে problems হয়. And that's the same reason why springs I used to discourage which formula? half fx. What did I recommend to use for energy stored? Half kx square. কেউ আমাকে কি বলতে পারবা? Remind me why we didn't use half fx and we rather preferred half kx square. Springs it. Yes. So যে কোনো কোয়েশ্চেন বলে যে হচ্ছে এই যে half fx, right? যে কোনো কোয়েশ্চেন বলে যে ফোর্স যদি বাড়ানো হচ্ছে how much energy would be stored? Most students will say what? ফোর্স যদি ডাবল করা হয় এনার্জি কতটুকু বাড়বে? 2 times. They're directly proportional, but the answer is not 2 times. It's actually 4 times. And the equation doesn't actually show that. Can Because when you apply force of double the value, extension কি সেম থাকবে? না, এক্সটেনশনে কি হবে? বেড়ে যাবে না? ওইটা অনেকে পিকচার করতে ভুলে যায়। It's not যে পারে না, but they just forget that extension তো পারে। তার জন্য দেখা যায় এই অ্যান্সারটা যখন half fx ইউজ করা হয় না। But half kx square use করলে is very easy. Why? Because k is always what? A constant, spring constant, right? So it's easier to just look at one value and compare. It's more like a safety measure for you making a mistake. আচ্ছা, তোমরা যদি অ্যাপ্লাই করো yourself সব ইকুয়েশনই কাজ করবে, বাট ওই যে ভুলে যায় অনেকে। ওকে, সো হাফ সিভি স্কয়ার ইজ আ বেটার ইকুয়েশন। যে কিউ বাড়ায় দিলে অনেকে ভুলে যায় কি বেড়ে যায় p, and that's why answer টা হয় না। Okay, anyways, these are equations and everything that you need to know to solve basic capacitor questions. To copy করে নাও, I'll add some notes here. বলো, which is half qv, q equals to cv, cv substitute করছি। এনার্জিটা আমি আলাদা একটা পেজে দিব। সরি, হ্যাঁ হ্যাঁ, মানে নর্মাল জাস্ট জিনিসটা আগে দেবো, নো এক্সট্রা মানে অন্য টপিক নেই। হাফ অ্যান আওয়ার, 1 hour. I know. I also have class after this. So, করবো বলো? Yeah. So I'm in control. Just extra continuation of what we were doing. I want to start magnetism. That's why I want to speed up. Just extra part. Parallel. Done. So yeah, the note that I have provided here basically tells you that capacitance is the ability to store charge, and it's measured by the gradient of the graph. The higher the gradient, the easier is it for to store charge. For a small potential, it can take in more charges. Shower. Quantum physics. Basic, right? তোমাদের এক্সামে আসছে এগুলো? What is this? এরকম casually সব আছে বলো। These are like massive chapters. Oh, না এগুলা। তুমি তো মেডিকেল ফিজিক্স আছে। ও আচ্ছা আচ্ছা, ওকে, ঠিক আছে। আচ্ছা, এটা একটু আবার বুঝাই নেই what this is. So the energy interaction theory জিজ্ঞেস করে, তার জন্য করা হচ্ছে এটা। So the energy provided to a capacitor from a power supply is QV, যেটা হচ্ছে যে this diagram here, okay. Right, so the energy that's given to your circuit by the battery is QV, but the energy that's stored is half QV. So why is that so? This is because half the energy is used to overcome repulsion from the electrons stored in the capacitor. So that's basically the thing, okay. আর একটা হচ্ছে, এটা জাস্ট অ্যাডিশনালি বলে রাখি, এটা একটা ফর্মুলা ছিল তোমাদের সিলেবাসে, they got rid of it, but it's a very useful formula. ওটা হচ্ছে what are the factors that capacitor depends on, and আমি তোমাকে একটা অ্যানিমেশন শো করছিলাম or like a simulation, remember? প্লেটস গুলো কাছে নিলে বাড়ে, বড় হলে বাড়ে. So what's the logic behind it? So the logic is something very similar to what you have done in your O levels with resistors. Can you tell me what's the formula for resistor in terms of its physical attributes? What's the resistance equation? Length, resistivity in length by area, right? Ekdom same একটা জিনিস এখানে exist করে capacitance. So Q equals to CV, we get it, right? But there's actually a formula for capacitance based on its physical dimension, and that C equals to epsilon naught. So epsilon over back করে A divided by D. তো আমি বুঝাই কোনটা কি। So D is separation of what? Plates. Okay, so these are plates এর মাঝখানে যে সেপারেশনটা, that's D. So separation যদি কমে, then what happens to your capacitance? Yes, so separation of plates. কি আমাকে একটু বলতে পারবা why separation কমলে a capacitor can store more charge? Yeah, exactly. Very good. So if you bring the plates closer, the positive charge is much closer now, so the electrons find it much easier to go. তার জন্য capacity বেড়ে যায়, okay? আরেকটা factor is the area. This is the area of the plates. So area of the plates barley can capacity bar is very self-explained. Bigger area means more what can come in charge, okay? So area of the plates, and এটা I hope পারবা তোমরা, because I've explained this. না পারলেও দরকার নাই. What is epsilon? It's a constant. There's a name for it. Epsilon. Yeah, that's the equation, which is yeah, it's permittivity of free space. Permittivity of free space is actually permittivity is the right term. Permittivity of free space is for vacuum. So permittivity is the ability of charges to interact based on what medium they're in. So Coulomb didn't know that. So Coulomb's original equation was what? F equals to K Q1 Q2 by D square. But then the K eventually turned out it was based only for air. But vacuuming a K would be different, water K would be different, oil K would be different. And then turns out the K has its own formula. What is it? K equals to 1 by 4 pi epsilon, right? That epsilon and this is same. And this is a measure of how, insulating your gap is. So তোমার যদি গ্যাপের ইনসুলেশন বেশি হয়, it's like a very good insulator. Capacitance কি বেশি হবে না কম হবে? বেশি হবে, because the more the insulator or insulating your gap is, the more charges can stick on the plates without jumping. You get my point? So imagine I'm using an insulator that's a very poor insulator. তাহলে কি প্রবলেম হবে? কিছু চার্জ যাবে and they'll just jump right away. But if I use a very good insulator, right, wouldn't it be able to keep the charges at bay because it's a very good insulator? Wouldn't that mean I can bring in more charges without this thing actually breaking down? So the better the insulation, the better your capacitor, and that is measured by this. Okay, so এটা তোমাদের লাগবে না, but এটা just হচ্ছে add করে রাখি. This is the property of the what? Dielectric. Okay, so তোমাদের যেটা জানতে হবে is capacitance is directly proportional to what? A, and inversely proportional to what? D. Okay, so এটা previously was a math and equation and everything. They got rid of this, but I have found that it is like it's helpful. Okay, there are easier solutions to some questions. So yeah, this is the energy part. Just to copy right now, I will now move on to the equations of charging and discharging. Just before that, I'll change that. So যাদের এটা copy করা হয়ে গেছে or you're done, you can try that math. এই যে এখানে question is. A capacitor stores energy and it has energy E and potential difference is 10 volts. Find the voltage or PD when the energy is when half the energy is stored inside the capacitor. উপরের পার্টটা কি কপি করা হয়েছে? So yeah, this question, try করো সবাই। Also আমি পাশে এনার্জি ইকুয়েশনস গুলো দিয়ে দিই, এনার্জি ইকুয়েশনস। Three equations for energy stored, okay, just like springs এর মতন। You got a different answer. What is it? In decimals? Okay, let me explain কেমনে করতে হয় এটা। So it says the energy stored in a capacitor is E and potential difference is 10, right? Find the potential difference if the energy was half. So you need to find out what's the relationship between what? Energy and voltage. এখন তোমরা যদি first equationটা use করো, ওই যে you'll face the problem. You'll find that directly proportional. তাহলে আমার energy half হলে voltage half হবে, and that should be 5 volts, right? But turns out it's not. আবার অনেকে ভাববে ও তাহলে চার্জ হাফ হবে, ভোল্টেজ হাফ হবে, তাহলে হচ্ছে 1/4 হবে, 2.5, সেটাও না। সেটা কেমনে করবা? সেটা করার জন্য we will take that equation into account, which is E equals to half CV square, and from there what is the relationship between energy and voltage? Right, exactly, energy is directly proportional to V square. Do you agree? আচ্ছা, এখন যেটা আমরা করব is just do unitary method. So unitary method কেমনে করব? If your energy was E, it had a voltage of how much? 10 volts. And then since directly proportional is not to 10 volts, rather কিসের সাথে? 10 square. Then if the energy is E by 2, what should the voltage square be here? 10 by 2 whole square. আচ্ছা আচ্ছা, okay. So এখান থেকে হচ্ছে V square. So if I do unitary method here, V square should be equal to E by 2 into 10 square divided by E. So এখানে E cancel out হয়ে যাবে. You get 10 square by 2, so 50. So therefore, V equals to root 50, which is 7.07 volts. That's the answer. Okay. Oh yeah, like taking K the constant. C. Oh yeah, so basically the constant then right. Clear it, huh? Okay, let's move on to the next one. So এটার জন্য can you go to page 112? Page 112. So I think by now you know the trend for A2 chapters is that they have a lot of graphs. So you're gonna learn 6 graphs now. Okay. 6 of them they're very repetitive, so I don't think it should be a problem. But start করবো তার আগে একটা জিনিস দেখে নেই don't listen. No, not break. Extra class পরে break পাবো তো আমাদের combination of capacitors কোথায় এটা দেখে দাঁড়াবো আচ্ছা it's in the first. Okay, sorry, we'll do combination of capacitors first because transient পরে আসে combination এর জন্য unfortunately I forgot to keep a space তো তোমরা যে কোনো পেজের পাশেই করতে পারো within capacitor chapter. Okay, so combination of capacitors, it'll just take one page. So একটু স্ক্রিনে দেখো also যাদের এটার পরে ক্লাস আছে এটা একটু দেখে যাও. Okay, it's important. Combining capacitors. So capacitor হ্যাঁ মানে ওটা পাশে করতে পারো আগে করতে পারো problem নেই just give the heading capacitor combination. So what is capacitor combination? It's kind of self-explained. What happens when you place capacitors in the combinations in series, in parallel, right? Does that make any difference, or are there ways to combine them? So let's say you have a capacitor here. Capacitance is C, and what we're going to do right now is we will combine this capacitor in different ways. Series, parallel, so let's start with the first one. So the first combination we have is a series combination. So series combination, your capacitors will go like this, just like how resistors combine. Okay, so this is called a series combination, and we will connect this to a battery. So how does this affect my circuit? Let's see. So the first thing is that the basic idea of a circuit interaction is still the same. What's the basic principle behind a circuit interaction? All circuits ever work under one fundamental idea or one group of ideas. What is it? ওটা circuit ছাড়াও হয়, but there are certain rules that govern every circuit ever. Right, what is that? Right, Kirchhoff laws. So Kirchhoff first law, Kirchhoff second law. First law is what? Conservation of charge, and Kirchhoff second law is what? Conservation of energy. And this is true for what? Every circuit out there. Capacitor thakuk na thakuk, it's going to be the same thing, right? Now that we have a capacitor, essentially Kirchhoff first law key state kore, the sum of EMF is equal to what? The sum of PD, right? So let's call it voltage total. Let's call it V1, V2. আর এখানে capacitor যেটা এটা হচ্ছে C1, C2, and the charge they store here is Q1, Q2. Let's try to find like connection between them. So according to Kirchhoff's second law, right? So according to KVL বলি, Kirchhoff voltage law, কিছু একটা equation আমাকে বলতে পারবা এখানে? What should the equation be in terms of Kirchhoff voltage law? Right, V total equals to V1 plus V2. Do you agree? Acha, now in terms of capacitors, right? Can you give me an equation for voltage? Q equals to CV, so V equals to Q by C, right? So I can write this as Q total divided by Q total divided by C total should be equal to Q1 divided by C1 plus Q2 divided by C2, and so forth. However, what are the charges going to be in each capacitor? So it turns out same. And the reason behind that is very basic. Imagine 10 electrons came from here, 10 electrons went there, and 10 electrons showed up here. How many electrons will it push out from the other plate? 5. যদি 10টা ইলেকট্রন এখানে আসে, 10টা ইলেকট্রন এখান থেকে কয়টা ইলেকট্রনকে সরাই দিবে? 10টা. 10 electrons will push 10 out, right? Why 5? So 10 electrons will go there. Now 10 electrons here will push how many electrons out? 10 again. And finally, how many electrons will come back to the battery? 10. We have satisfied which law? Kirchhoff first law, the conservation of charge, right? So therefore, in this circuit, we can say that in a loop, in a closed loop, what is Q1, Q total, all equal, right? So therefore, if that's true, what can we do to them? Cancel down because they cut out, right? So therefore, the combination of series capacitors is going to be 1 by C total is equal to 1 by C1 plus 1 by C2. And you will remember that this is similar to what? No, spring combination. Spring series is এরকম হয়, resistor কি series এটা হয়, resistor series কি হয়? Yeah, R1 plus R2 plus R3, right? So this is basically the other way around. And I'll let you in on something. Resistors is a problem. Like every other thing combines this way, series. So capacitors, wiring system, তারপর হচ্ছে springs, right? তারপর I think there's the way water flows in a pipe rate. সবকিছুর combination হচ্ছে if they're in series, it's like an inverse addition. Our parallel থাকলে কি হয়? Just normal addition. Resistors just happen to be a little off or ulta. Okay, right. Anyways, this is the combination for what? Series combination. Now let's do parallel. So parallel টা তোমরা আমাকে help করবা. So yeah. হ্যাঁ, so এখানে যদি 10টা ইলেকট্রন এখানে আসে, right? ইলেকট্রন তো এদিক থেকে এদিকে যেতে পারবে না। কেন? হ্যাঁ, ক্যাপাসিটর। But এখানে যদি 10টা ইলেকট্রন আসে, can these electrons repel electrons on that side? Yes, because there's a field out there. So if 10 electrons move in here, how many electrons will be pushed out from there? 10, right? Always. It's a metal plate. Right, now let's look at this one. This one is your parallel combination. I'm পুরোটা একসাথে দিব, তোমরা কপি করে নাও, but আগে বুঝে নাও। এটা derive করতে দেয় এক্সামে। Very easy derivation. যেমন তোমাদের রেজিস্টারে তো ছিল ডেরিভেশনটা। Right, so tell me what is going to be the quantities that are same and quantities that are different. Okay, so let's start. From Kirchhoff laws, right? In a parallel combination, what is same? Voltage. Okay, so এখান থেকে যে চার্জগুলো যাচ্ছে ওরা যখন এখানে স্প্লিট আপ হয়ে যাচ্ছে ওরা তো সেম এনার্জি নিয়ে যাচ্ছে, per coulomb charge. So এখানে যা ভোল্টেজ এখানে সেম ভোল্টেজ, but according to Kirchhoff law, if this is Q total, right, how does Q total compare to Q1 and Q2? Sum, right? So this is now going to be according to the charge law. So according to KCL boli, current law, what can I write down? Q total is equal to what? Q1 plus Q2. And Q happens to be what? Equal to, in capacitors, CV, right? So I can write C total, V total equals to C1, V1 plus C2, V2. And in this kind of a loop, right, in parallel circuit, in parallel, V total is equal to what? V1 equals to V2, right? So if that's the case, what can I do to the V's here? Cancel them out. So V cancel this out. And this is very easy. The parallel combination for capacitors is essentially that. তোমরা কি mathematical implication বুঝো এই addition or এই addition? Like mathematical implication মানে হচ্ছে how does the math work when you have this kind of an addition versus that kind of an addition? Acha boli, maybe my question wasn't clear. When you have this, it's just for an arithmetic sum. In an arithmetic sum, whenever you keep adding a component, the value will keep on increasing, will keep perpetually increasing. So there's no way that I can keep adding something and it decreases. And these can't be negative numbers, these are positive integers, right? So there's no way to decrease this. In an inverse ratio, the more you add, the lower the value becomes. So if you remember from your circuit resistor combination, the more resistors you kept adding, what happened to your total resistance? Decrease. In parallel, our series, the more resistor you added, what happened? It increased, right? So just keep that in mind. So it means that if I want more capacitance for my circuit, I should add them in what combination? Parallel. Or if I want less capacitance, I will put them in series. Okay. T type of question আসে এখান থেকে তোমাদের exam multiple types, but most common হচ্ছে they'll give you like a basic circuit. Recent years যেটা করে, which is I feel a little unfair, they'll give you capacitor values Well, we draw a combination that gives a total of certain number. It is, I feel, like, waste of time. Because it's basically, they're giving you numbers of 1, 5, and 7. Well, they say, like, combine korle, you can make 200. You don't need physics for this. You just have to know how to use different permutation combination and come up with the answer. Like IQ tested that. You have 1, 5, and 7. You can use plus, minus, division, multiplication, solve, combine and get me 200. Like, in 4 steps. তো এটা তো physics দরকার না তো। তো তোমাদের যে capacitor question ওরকমই দেয়, that you have capacitor of 30, 40, and 50. Combine them in series parallel to get a total like combination of 15. Now, yes, একটা idea add করতে হবে যে যেহেতু 15 আসছে আমার total, it's less than all of them, right? So it must have been a what combination series, right? So you get my point, right? O2 maybe is what you need, but rest of them I feel is little, unrelated to physics. Okay, so ওগুলা দেয় ওরা, right? So there you go. These are the combinations. Copy করে নিতে পারো, and